Okay, this is our review period. So I've come with no content whatsoever. Please enlighten me about what I can do to help you ahead of tomorrow's exam. Yeah,
So for code smells, do you want to start like every single code smell subcategory of it? So like the blow has like increased size, or like it has like many subcategories, like too many good names, or
yeah. So I would know the associated category for a particular code smell. I'm probably not going to ask you, I'm going to try not to ask you memorization based questions like for this exact code smell, something, something, something. But I might ask you to generate a code smell given a particular category, like something like you show me that you understand a particular kind of code smell and then analyze it, tell me what it is, tell me the reasons why that particular smell is bad, what we can do instead. Something like that.
so use narrow it down to like one thing instead of like all of them.
Yeah, so I would say know the smell, but also know the category of the smells as well, or be able to talk about, if I were to ask about a category in general, like what is bloat? What are the different ways that bloat can appear in your code? Then you can think about the different ways that there are different code smells that are related to bloat in your code. What else?
I
Yeah,
have to ask, are these review sessions recorded?
yes. I'm trying to upload them as quickly as possible after the classes too. So 300 is already up. And my goal is to get this one up as soon as the class is over. Yeah,
So for the UML diagram, about the relationship, what was the difference between is a and has a relationship?
yes, let's talk about that. So is a versus has a talks about the different relationship types with regards to either a superclass subclass relationship. So we have some superclass and some subclass that inherits from it. So this is an is a relationship. Because if we wanted to give examples of this, maybe we have if we have animal and cat as a superclass and a subclass, and a cat is a animal. It is an animal, but it has an is a relationship between the subclass and the superclass. You can even see that in things like the factory that we just did, where a New York style cheese pizza is a pizza. It is a part of the superclass if there is a subclass associated with it. So is a defines some kind of inheritance hierarchy, subclass is a superclass. Has a is when you have composition. So this is we have something like, we used composition in a decorator as an example. So if we have some kind of large scale object and one of the fields in that object is an instance of some other class, then this is has a relationship. So this has one of those as part of its state. So maybe this is a chair class and a leg class. A chair has a leg. In fact, it has multiple legs. Maybe it has a leg array, but it's a has a relationship. A chair is made up of or has some subcomponent. It's not inheritance because we're not getting any of the behavior from the chair or from the leg to define the chair or from the chair to define the leg like we did here. We could abstract some of the cat logic up into the animal. But when we have a has a, it's more of a component of. Yeah,
So is generalization the same as inheritance?
yeah, generalization is the name of the relationship for an inheritance relationship. So we have generalization as the relationship between cat and animal, because a cat is a type of animal. So you can think of this as a generalized cat. It's also a generalized dog or a generalized squirrel or any other animal that you might think of, but this is more abstract or more general than this. So the relationship is one of generalization.
Pro and cons of UML, sure.
Pros and cons of UML in general. So pro, it can do a lot. It's very visual in nature, which means that it's very accessible between people who have different levels of technical experience. We find this a lot in industry when we're working with clients who they don't have the same technical background that we do. So we can describe our project and communicate about our project in a way that is stripped of all technical terms. And it's a way of saying, is this the service that you would like me to implement? And it allows them to draw and explain things as well in a way that allows for that communication. There are lots of different kinds of diagrams, which means that we can communicate lots of information concisely and clearly. Some of the detriments is it doesn't have a great technical background. It comes from lots of different places. So there's not one technical specification way to produce different diagram types. In fact, you will see lots of similar looking diagrams that are called the same thing. And it just depends on where you work, the background of your manager as to what they're going to expect. So there's a lot of different, it kind of feels thrown together, I guess would be the way to put it. It feels like a lot of people came up with a lot of different ideas and we put them all in a blender and said, look, we have UML.
So it's like a generalized thing instead of like a standardized.
Yeah, it's not very standardized. It's a great way to put it. There's no hard set rules about exactly what needs to be done for a particular diagram type. There are lots of different interpretations of that. So there are lots of different modeling languages out there, and this is the union of all of those modeling languages. Yeah.
Aggregation versus composition.
Aggregation versus composition. So I call this composition, but it could also technically be aggregation. A chair does own its legs, but the big thing to think about between aggregation and composition is ownership. Is there ownership? Can they be freely switched out? So let me bring up the slides for this so we can talk about it. I think that showed it quite well. erase this for a while. All right, so we talked about how regardless, we have classes belonging to collections, so it's the same between each. The question is, can they be shared? And is there ownership? And then there's the associated difference in how they're drawn in the UML. So hollow diamond versus filled diamond as the way of denoting aggregation or composition. So we talked about how projects and consultants, there's no really ownership there. A consultant can switch between multiple projects.
What do you mean by ownership?
So like a car owns its wheels. You can't remove the wheels from a car. You can remove the tires, but not the wheels from a car. They're built into the car as part of the car. So the car owns its wheels. Whereas a consultant could be a consultant between multiple different projects, maybe not at the same time, but there's not necessarily an ownership. You could swap out the associated consultant for a particular project and continue the work. Similarly, we have aggregation between this class and students. Because this class does not own you, you're free to get up and leave. You also attend multiple classes at the same time. Whereas this classroom doesn't really have legs. It can't get up and leave the Catalyst building. It's kind of locked into the Catalyst building. It will be in the Catalyst building until it is demolished. So there's ownership, strong ownership implied between this building and this classroom. Can't easily be changed. We then had the code example, where a car and an engine could either be aggregation or composition, depending on how you want to think of, if when we put an engine in a car, is that the car? Can we take the engine out of the car? Technically, yes, we can, but you could construct it in such a way that it is not. The car is the engine. So we have, notice how we can now pass in the engine here. So when we set this engine at construction, sorry, that's not part of the constructor. This is just part of you just get to set it. So this is more aggregation. Whereas we have a final engine. This is the final engine that will ever be in your car. So that is composition. At creation time, when we make the car, we make the engine and associate it with this car. So we can't remove an engine from a car and still call it a car. An engine is part of the car. There is no car without an engine. When we want to move the car, it has an engine. There's no way we can remove this engine from this car. Whereas here, we can freely remove an engine, swap an engine. So we need to check whether it has an engine before we ask the engine to do something. So the key differences was the keyword final, the fact that the engine is kind of linked up at creation, coupled at creation in a way that we can't uncouple them. And here, we just kind of put the engine in the car, but the car can exist without the engine. In fact, we could swap out the engine because this isn't final. This engine could be removed and replaced with another engine if we wanted to. So there's a strong has a relationship and ownership implied. No ownership implied, we can swap it out. Yeah.
Could this type of code step be something on the exam?
I probably wouldn't have you write this, but I might have you analyze something and say which one of these is composition, which one of these is aggregation, and why.
Would you have us build a UML diagram?
Maybe. Especially one that's related to a design pattern as a way of showing that you understand how a design pattern is supposed to be constructed. It may be easier, and I could kill two birds with one stone by saying, make a UML for this rather than describe it in English. If I did that, then I could test both your understanding of UML and your understanding of the design pattern. And I also have two ways to give you partial credit. Is it a bad UML with a solid understanding of the design pattern? Is it a good UML with not so good of an understanding of the design pattern? That'd be multiple ways to give you partner credit. So those kinds of questions are usually what I try to design.
Go back to slide one.
What else? Yeah.
Pro and con design patterns at very high level.
So design patterns are quite the tricky beast. They certainly solve problems. So I would say pros are they target minimal time extendability and modification. So if we need to make changes to our code, which is a very real world thing that we do, the requirements and specifications are changing all of the time, especially while we are developing the application. So if we can structure our original code design and implementation using design patterns, then when things change, it's not a matter if things are going to change, when they change, then it will be a minimal amount of work to do that, assuming understanding of the design pattern. So I would say that is a massive pro of design patterns. They also adhere to lots of standard object-oriented principles, like encapsulate what matters, because a lot of design patterns are trying to encapsulate and take burden off of the client and encapsulate it inside of its own object. So the client has less to do, the client needs to understand less about the code and how it works in order to interface with it. So I would look at all of your object-oriented related design philosophies and try to link those to the design patterns and say, how do design patterns help us with those kinds of things? The cons for design patterns is they really increase the complexity of the code. So there's a much larger barrier to entry. You need to understand a lot more about programming in general. And there are a lot more ways that something could go wrong if you don't have that full understanding of the design pattern. If you make a mistake implementing the design pattern, it's going to be difficult to find. If you have a very large project, a large intellectual scope, you're going to have significantly more code to manage if you apply the design patterns than if you don't. So large code that's easy to modify and change, smaller code that is more difficult to change. There are pros and cons to both of those design philosophies. Another con to design patterns is usually by implementing one, you're going to create some other issue in your code where the solution might be another design pattern, or you might just be offloading what used to be one problem to another place. It's not as wrong here, but it's now wrong over here. And depending on the scope of your project, that might be a good thing. If you're not interacting with this very much, and you're interacting with this all the time, then it's very useful to offload the problem over here so that your code runs better in this fashion.
So essentially competition is really greedy.
Greedy?
Yeah, they hate sharing. Competition hates sharing.
Yeah, you could think of it that way.
Migration is like happy to share.
You could think of it like that.
And sometimes you want no sharing.
Yes,
And sometimes you want to share.
exactly. I don't want to share my wheels with any other car.
Because that'd be really awkward. Like,
That would be really awkward.
So when we say client, we mean the driver class?
If it's, yeah, that's a client class, yeah, the client, the person who's using your application would be interfacing with the tools that you wrote in some capacity. When you write a driver class or a main, you're using the objects that you've constructed. So usually what you end up doing is having an API for something like this. Like you can, let's use Google Maps as an example. Let's say you want to embed Google Maps in your own website for some reason. The API for that is going to try to make that process on you as easy as possible. As much of the underlying difficulty as it is, you want to encapsulate that inside of the logic of Google Maps and not force you to have a bunch of technological understanding and trying to figure out all of the network logic or any of the other complexities that you might have when trying to make sure that you're able to communicate with Google Maps in real time on your own site. You want to make it as easy to use as possible. If you're trying to create something like accounting software, now on the other hand, accountants are not computer scientists. They don't want to think about computer science related problems. They want to think about accounting related problems. So good software is going to hide all of the computer science related technological stuff inside of the program. And then the end user, the accountant, only needs to, using accounting technology, type things that are related to accounting to interface with your computer science project that helps them with their project. So usually it's found in API design, driver class design. You want to minimize the work that's done there and maximize the work that's done underneath the hood.
Can you walk through this?
Yeah. So the strategy pattern is for encapsulating algorithms in their own class. That would be the one sentence explanation if I wanted to have a one sentence explanation of the strategy pattern. We have some process and we want to encapsulate that process in its own class such that when we want to use it, we can swap it out at runtime. I'm going to use a data structures analogy because I think that that would be really useful, and I really wish that everyone who was in data structures was also in this class so I could make this a requirement. One of the things that I had to do in data structures was write associated basic sorts in different linked list classes. So for those who aren't in the class, we have a singly linked list, a doubly linked list, and a circular linked list. We want each of these linked lists to be able to sort themselves in different ways. We want to be able to sort a singly linked list using insertion sort. We want to be able to sort a doubly linked list using selection sort. So to accomplish this, the silly way to do it, which is the way that I assigned, is to embed the logic for each of those sorts inside of each of those classes. So we would have, I'm going to disconnect this. I don't think we need it anymore. We have a class that is a singly linked list. And inside of that singly linked list somewhere, there is a method called insertion sort that has the associated logic of all of the ways to sort this particular list. There is also a selection sort. There's also a bubble sort. In this other class, we've almost copied and pasted. In this doubly linked list class, we've almost copied everything over into that class. We know that copying and pasting is not ideal. So if we wanted to apply the strategy pattern to this, what would it look like? How could we apply the strategy pattern to these linked lists? Pull them out and put them in their own inheritance hierarchy. So we're going to have a sort interface. And then from this, we're going to have the insertion sort class. We're going to have the selection sort class. And we're going to have the bubble sort class. They all adhere to the sort interface. Now, instead of writing the logic for this inside of these classes, we're going to have a field that is a sort variable. When we construct a singly linked list, we could have a default that says S equals new insertion sort, or S equals new selection sort, that instantiates this logic and then allows us to compose the singly linked list or doubly linked list with one of these sorts. when we want to go sort the list, now instead of calling SLL dot insertion sort or selection sort, whatever we named the instantiation of this object, we just say dot sort. And the dot sort would look at the type of sort that this is and apply the associated logic of that algorithm. Note that now, if we needed to add additional linked list types, maybe we have a circular singly linked list. We wouldn't need to redefine insertion sort, selection sort, and bubble sort for that new linked list. We just need to make sure it has a field that can be set to one of these three types, and it will automatically be able to sort itself. So we've increased the extendability of our code by saying we can make new list types that all have the ability to sort itself. And we've created a composition between this sort, actually pointing the other way. A linked list is made up of a sort. What this also tells us is that at runtime, we could make a method called setSort that takes a sort object and sets this field to be a new sort type. So we could do something like set sort new bubble sort. And that would change how our lists sort themselves at runtime. In the middle of our code, we could query the user and say, how would you like to sort this? They say how they'd like to sort it. We instantiate one of those objects. We compose the list that they made with that sort, and then that list will sort itself that way. This also means that we could add additional sorts here. So as you learn recursion, you could add merge sort as a type of sort. And then all existing list types with a single implementation of merge sort would allow you to be able to use merge sort. Or quick sort, or heap sort, or radix sort. Or BOGO sort. Please don't. Does that help the strategy pattern make more sense, maybe? Seeing it in terms of something that you have hopefully also seen before, either in this class or another iteration of data structures. So the strategy pattern is saying, instead of embedding algorithms inside of objects, we are going to create our own hierarchy with its own interface. And we're going to compose some field of this object with one of these algorithms. The benefits we get from that is we have runtime swappability. We have extendability both of the algorithm, we can add additional sorts, or the object, we can add additional linked list types. Yeah,
I'm just wondering what you mean by being able to write code or fill in lines of methods to give a code that adheres to Shai's methods.
so if I were to say something like, if I gave you the code for a linked list type and it had embedded in it insertion sort, selection sort, and bubble sort, could you tell me how to design this in terms of the strategy design pattern? Don't write the code for any of this, but maybe talk about what I just talked about with regards to pulling that out, making it a field in this class, pulling this out into its own interface and its own hierarchy and composing the field, the new field of the sort type with the associated sorts. If it were something much simpler than this, then maybe I ask you to write a little bit of code, but it's not going to be much. It would have to be a very small problem for me to be okay with that.
What do you mean by why do we bother categorizing code smells?
So we had our different code smell categories. We had, we had our bloat, we had our object-oriented abusers, we had our couplers, there were a couple others. But we have these different categories of them. Why do we group them together? And it's so that we can determine what category they belong to. We're kind of look at different code smells as similar issues. So code bloat is a big issue. If I just introduced 40-something different code smells to you, I wouldn't be able to abstract and talk about one of the big issues in code design is code that doesn't need to be there. What are all the different ways that you can implement code or that code can become legacy in ways that we don't need that code anymore? Or we designed for code that never got written because the functionality changed. So there's some existing code that just doesn't need to be there. Those were dispensables, but a larger scale bloat issue would be like long methods. It's difficult to read. What are all of the ways that we could create code where we have difficult to read code because some aspect of it is just too dense? It allows us to abstract that logic into a bigger problem and talk about the bigger problem at large. They cannot. Design patterns cannot be automated because they're problem specific. And the reason that is how is the strategy pattern here? Could we come up with a way to, like we can, getters and setters can be automated. Because we can analyze a class and say, what are the fields? List them. Come up with a way to do this. And think about probably something that's a little bit more complicated than the strategy pattern. Think about the factory pattern that we just went over. Would there be a way, given an idea or a set of classes, to say, come up with an autofill a factory method for these? It's a more design-based philosophy. You have to look at what do I need out of this project? How can I adhere to this idea of encapsulating the object's creation while still adhering to all of my requirements and specifications? All of those would need to be input into some kind of automated system that would still probably get it wrong, given the needs of your client, given there would need to be some kind of long scale specification that would need to be done to even hope that something like ChatGPT could generate something like that for you. Maybe one day we have an understanding of that. Maybe we can use deep learning and tens of thousands of implementations of the factory pattern to come up with some kind of automation for that. But it's not going to be something like import crazy useful code dot library pattern, pattern dot magic. It's not going to happen. Like you can analyze a class and come up with, all right, for every field, we could write a getter for it and a setter for it. And the syntax for that is always the same. We just look at the type that this is, and we return that type from a getter, and we take that type for a setter. Done. That's automatable.
Are there any certain or additional considerations when fixing this?
Depends on the spell. So if we look at, I'll plug this back in so we can look at some of the code smells slides. I'll give you an example of what I'm talking about there. So I mean this on a per smell basis, but let's say it's something like this, beware. What additional considerations need to be done to apply data clumps? So passing a whole object in the parameter of a method rather than passing just its values can create an undesirable dependency between the classes. That's something that we need to consider when we want to do something like create a data clump. It's an additional consideration, and it might create a reason why we don't want to adhere to this. We don't want to fix this data clump. Because we care more about not having a dependency between these objects than we care about identical groups of variables between two different classes. So as always, there's a lot of design pros and cons analysis. This is undesirable if it can be fixed with no repercussions. Sometimes the repercussions to fixing this are worse than the issue that's already there. But that's problem dependent.
What's the difficulty of this exam compared to the last one?
Depends on how prepared you are. In general, I would probably say that it's harder. That said, there are more points available and it's graded out of the same.
114.
114 was for 300, this one I think actually has 120. So there's an extra 20% available. I don't lop off at 100, so if you score more than 100, maybe this is an opportunity to be able to take it a little bit easier later in the course or have a little bit more margin.
Well, know what the kinds of, diagrams are.
Yeah, lots of the different kinds of UML diagrams. So we talked about quite a few different types, but the overview that we had was this one. So we had use case diagrams, class diagrams, object diagrams, sequence diagrams, activity diagrams, and state diagrams. Let's talk about each of these. So use case diagrams are for explaining an entire system. So we have a system. Who is part of the system? Who's responsible for what within that system? So one of the examples we had in our slides is like a restaurant. So we have the client, we have the waiter, we have the cook, we have the cashier, we have different people who are interacting with the other different users in different ways at different times. So a use case diagram's job is to explain that, to be able to explain what are all of the different interactions. Who's involved? What are they responsible for? When is this being used? For what? How? Class diagrams explain the underlying code at a class level. So instead of just looking at a project in IntelliJ and trying to figure out what does this do from the associated project structure, and then the code, when you double click on a class and it brings up the code for that, trying to figure out what the structure is and what each of these classes do, it's a much more succinct way of basically, it's very similar to an interface. It's going to list the fields and the methods and the return types of those methods. You basically get the method signature, and that defines each class. So an example of that, we looked at with stuff like this. So for each class, we get the list of fields separated from the list of methods. And now we get a sense of, all right, what is an activity? It has a number, it has a description, it has a start date, a number of hours, and whether it's deliverable. I guess, what can an activity do? We can create an activity, we can set the associated number, we can get the number, we can set the description, get the description, set the start date, get the start date, set the hours, we can destroy an activity. So this tells you the things you can do to an activity. So state, behavior, it gives you a much bigger overview that would take you a while to do if you were just looking at this code. It's a much more visual representation of the code. Next, we had object diagrams. That's kind of the same. So for structural models, we have class diagrams that show the different classes and the relationships between those classes. And object diagrams kind of zoom in on those individual objects to talk about what do these objects do. So class diagrams also have the relationships between classes. So a project contains many, many different activities. We have I think it was generalization between activity and project. A project is made up of multiple of them. Sequence diagrams show how different processes are broken down. So we had something like, how does the check email work? How would your check balance on a bank account work? Who is responsible for sending which calls where? And how does the communication of this process work? So this would be something like breaking down one of the arrows of a use case diagram that says, when the waiter delivers the order to the cook, what is the sequence of, what does that look like? Who's responsible for doing exactly what and when? How is the information passed between different entities? We had activity diagrams for things like ordering something online, where when a user goes through the ordering process, we wanted to see what does that look like for them and who's responsible, what different departments are passed information and when. And then finally, we had the state diagrams for things like the button. Like you push the button is on. You release the button is off. So you could look at an internal state of an object and define what happens to that state. So if we're going back to the class diagram, we could look at any object or any field of an object and kind of zoom in on that field. What is the state of that object at any particular point in time, and what interactions need to be done to change the state of that object? It could be something as simple as a Boolean button that's either on or off. It may be an integer. There may be some internal state of an object that is constantly changing. You could look at something like the state of a vending machine. Does it have money in it? Yes or no? You can add money to it, in which case the total field would be changing as you put in dollar bills or coins. And then you attempt to purchase something. And if you have enough money for the purchase, either the purchase is successful, in which case the cost of that object is deducted from the total and the object is returned, -1, the total quantity that's inside of the vending machine. So you can imagine making a state diagram for the internal state of a vending machine. It contains some number of things for purchase, some amount of money, and how does that work? As you add money, as you try to order an item, what are all the possible states and state changes? We also looked at a beer mug as it was in use, being filled, being cleaned, all of the different interactions that could have with it and the different states that it could be in as those interactions happened. So these are the only ones we really care about, but pay a special focus on class diagrams and object diagrams, because those are the most important for our consideration. We're not designing a large scale project. Come 350, you might care about some of these other types. But for now, we really mostly care about being able to think about our code and represent, if we're looking at a design pattern, what we have are a bunch of different classes, and those classes have components and relationships between each other. So trying to understand the strategy design pattern in terms of what classes are there, what are the relationships between those classes should be good enough for this exam.
Can you explain why we favor composition over inheritance?
Yeah, so when we have the inheritance, if we're looking at just having inheritance, if we need to expand upon that, then we need to duplicate our logic upon an ever-growing number of subclasses. So we have some superclass, some number of subclasses for this, and we want to add some subclasses to this. If we have the associated logic for this, then we'll find, let's say we want a new variable for this. We want to make, maybe this is a color and maybe this is a size. So for each of red and green and blue, we now want to have a small red, medium red, and large red. So now we have an expanding number of subclasses as we want to expand upon, increase the number of variables, increase the number of subclasses. If we're just using inheritance, then this is a problem. If we compose, so we say now, instead of a superclass and some number of subclasses, we're going to compose this object of a color and a size. Each one of these are their own hierarchy where we have a color and red, green, blue, and we compose, and we have a size. Small, medium, and large. We end up with way fewer classes. We don't have a multiplicative relationship, we have an additive relationship. And this also gives us the ability to swap this out at runtime. When we make a new object, we can now say size equals large, and we can start to swap this out at runtime. Whereas before, we couldn't change the size without also changing the color. Like we had to completely change the subclass. Instead of a small red, we wanted a large red. And that completely changed everything about the underlying structure. So composition is very important for this. It reduces the total dimensionality and increases the extendability of what we're doing.
So in this example, the color and size interface, in the color and size, one of two classes, these are the super classes, and all the lower one are the subclasses.
Yeah, these would be interfaces. Yeah, I should probably specify. This is an interface. This is an interface. And then we have, yeah, subclasses that implement that interface.
In that color and size, the middle one is the abstract class.
This would be some class that wants to use this. So this could even be a concrete class. This could be, I don't know, what has a color and a size? Car. We can make a large red car that is some kind of monster truck. We can make a medium red car that is an SUV, and a small red car that is a compact. And maybe this is even a concrete car. There's only one kind of car. This changes exactly what is produced.
So in this situation, the class in the middle will implement both of these interfaces.
Yeah.
So we are allowed to implement two interfaces, but not
Yes.
two inheritance.
Correct. Yeah, we can only extend one class, but we can implement an arbitrary number. We're out of time already. How did that happen? Seems like we just got started. Maybe that's just the professor's view of the state of the world. You're probably thinking out there, this class has been going on for 5 hours. Can I leave yet? Any other questions I can answer with 0 minutes to go?
This is mostly more design, is this more knowledge heavy or code heavy?
Probably more knowledge heavy than code.
Okay, mostly the knowledge of the patterns themselves.
That is a section of it. So you should know the strategy pattern. That's the only pattern that's going to come on the exam. No decorator, no builder, nothing after strategy. So you have not turned in and gotten your labs back for that yet. I'll be up in my office if anyone has individual questions that I can answer.
Complex you think that need now on this?
Most complex thing,
Yeah.
details of code smells. That's probably what there's the most of out there.
Yeah.
I will say that you don't need to memorize all of it. I'm trying not to make it a large memorization based topic. But you should be able to explain aspects of it at a reasonable level. It'll be more so you design the problem and the solution rather than I tell you, do you know this detail about this exact code smell?
Are you able to complete, questions about office hours before the exam tomorrow too?
Yeah,